to the Right Brothers channel. Today we are going to continue our topic on principal component analysis. Before getting into this, I suggest you to watch my previous video so that you will get a clear picture of this concept. In the previous video we have discussed overfitting and underfitting. So these are the two problems that gave rise to this principal component analysis. In the overfitting, the model tries to satisfy each and every data point, whereas in underfitting it is quite reverse. It is far away from almost all the data points, whereas this principal component analysis gives us the best fit line or the best fit model that satisfies almost every data point but not the every data point, because if it is satisfying every data point, it gives rise to underfitting, or else if it isn't satisfying as many data points as required, it is going to lead to underfitting. So this principal component analysis gives us the best fit with the help of the principal component. So in this we are going to find the best principal component from out of a number of principal components. So let us see what are those principal components and what is the best fit principal components. For example, let us assume that from this point of view we can observe that all these data points seem to be overlapping on this line. So now we can draw this line in such a manner that like this. So all the data points seem to be overlapping on this line. Let us assume that this is the principal component 1, whereas let us assume another principal component from another direction, in this direction. Here you might get a doubt that only a single point like this of this line will be visible, but no, let us draw an imaginary line like this. Now these data points seem to be overlapping like this on this line. So this line will be the principal component 2, that is PC2. Now we need to find the best principal component that is satisfying all these data points or some of these data points, which gives the best output soon after training, means which develops the best intelligence. So here there are two attributes, X and Y. Now here we are going to discuss the important point. The number of principal components, the number of PCs should be less than or equal to the number of attributes. Number of attributes. So here we have taken PC1 and PC2. That's it. Only two components can be taken, principal components can be taken, because there are only two attributes. So from these two principal components, we need to find the best fit principal component. So we will find this best principal component with the help of the mean, covariance, using eigenvalues and the eigenvectors. So before getting into this, one other important point I just want to tell you is that these two principal components should be orthogonal in nature. It means that any principal components, any two principal component should be independent of each other. Means this principal component should not affect the value of this principal component 2. So you might be getting a doubt that will there be only two principal components? No, based upon your attributes. For example, here you have taken the X and Y. Now, if there are three attributes X, Y, Z, then you will be having PC1, PC2 and PC3. That's because, as I have said you earlier, number of principal components should be less than or equal to the number of attributes. And these three principal components should be orthogonal to each other. PC1 and PC2 should be independent of each other. PC2 and PC3 should be independent of each other. Similarly, PC1 and PC3 will be independent of each other. It means that these principal component 1, 2 and 3 will not be affected by any of those values. Now, soon after you find these principal components, you are going to assign the priority to them. In the next video, I am going to explain you how you are going to assign the priority to the principal components based upon this mean, covariance, eigenvalue. Hope you understood the topic. For further queries, I suggest you to mention them in the comments below. Thank you.